Hello, this is Jose Luis here at Parametric Camp and welcome to another video in our series Advanced Development in Grasshopper. In this video, I'm going to show you a few pro tips on how to streamline your development and your testing in your Grasshopper components. So for example, I'm going to show you the technique to add a breakpoint so that when you are developing and you hit, for example, I'm going to recompute and you hit like a certain part of the code, you can stop the execution and you can take a look at what is happening here. Can I look at the code, how it's moving from one line to the other? And then can I see the results of like, yeah, this is the mesh, etc., and then continue the execution. So you can pause and take a look at that. I'm also going to show you how to do what's called hot reloading, or for example, the idea that I can now change the world calculated, blah, 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 whatever, and then I can hot reload. And therefore now when I run this code again, recompute, you can see that the changes have been broadcasted here, all right, without the need to set breakpoints and restart everything. And I'm also going to show you how to measure performance. So you can see that now this code knows how long it took to execute this code. And so that's a very simple trick using just the stopwatch class in C#. All right. So this is just a few tips to help you debug, understand, and look at what's going on in your code when developing Grasshopper components. Okay. It's going to be super nice. Let's take a look and dive in. The first thing that I would like to show you as a technique for testing and debugging is one of the most common methods for debugging that I know of in pretty much any development platform, which are called breakpoints. And the idea is that if you're using some kind of development environment like Visual Studio that also handles the compilation and also handles the execution, or let's say the opening of a process that is going to be running whatever code you are writing. If your development environment handles the execution of that environment, then very likely you will have the possibility of establishing breakpoints in your code, which basically means saying or telling your development environment that you want to stop the execution, you want to pause the execution of your software at that particular line of code whenever that line of code is hit. And you want to take a closer look and you want to inspect the state of your software when you hit that line of code. So for example, what would that mean in terms of Grasshopper? In terms of Grasshopper, what that means is that, let's say we are working on the remesh component that we had before, that component that that took a mesh and a bunch of data and then output another mesh that had been changed in topology, right? So because let's say that this component, we had some questions about what's going on. We needed to take a look at the remeshing operation, etc., etc. So something that we could do is we can say, well, the most interesting part of this component is arguably the solve instance function, because that is a function that gets called by Grasshopper whenever the component actually needs to do its job, right? And this is where we write our main code, if you will, which in our case is very thin. It's just like remesh to target, blah, 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 right? And which is calling this other function. And then this string that we put out in the, that we output through the debugger that we just wrote in the previous video, right? So let's say that for some reason, I didn't know exactly what was going on. Some numbers were off. I was getting errors, whatever. And what I could do is I could say, well, I want to execute this, but I want Visual Studio to pause the program whenever this line of code is executed. So what I can do is I can click here on this gray bar on the left-hand side of the numbers. I can click here on this gray bar and establish a breakpoint. And what that will do is that when this component gets executed under the Visual Studio development environment, then Visual Studio will stop the execution of everything and give you a way to take a look at what's going on. So let me show you what that looks like. So I established a breakpoint. I'm going to run my plugin from Visual Studio Code. And if you remember from previous videos, we have configured our whole development environment so that when I click run, then I open Rhino, and then Rhino is going to open Grasshopper with this file that I'm using for testing and debugging. I actually don't know if I explained this, but I'm going to explain how I did this also in this video. Anyway, so what you can see is that my software, my environment is running perfectly. This is the remeshing component that I am targeting, but you can imagine that you can see that right now nothing has paused. So my Grasshopper is still responsive. I can move Rhino, etc. Because this component has not run ever. This component has not had the solve instance method call because it doesn't have any input data. So let's say that I were to create some kind of mesh, for example. Let's say I'm going to create, how can I say, like a primitive mesh. So for example, a cube or a box, right? Something like this, right? And then I'm going to load this into Grasshopper. As I do that, you can see the boom, everything just paused. If I were to go back to Grasshopper, I really cannot. And you can see that Rhino and Grasshopper are both frozen. I can see I cannot drag, I cannot do anything. They're both frozen because Visual Studio has stopped the execution of everything and is right now stopped at my breakpoint. You can see that I have a continue button here. You can see that I have a way to just stop everything. So right now, Rhino and Grasshopper are paused in this component that is about to execute. And what's interesting is that this also allows me the possibility to inspect the program. So for example, this is the moment where remesh to target edge length is going to be called. So what I can do is with these tiny buttons here, what I can do is I can follow line by line the execution of the program right now. So let's say that if I press step into, what's going to happen is that the program is going to move on to the next line of code, which is executing this function. And I'm going to step into again, and you can see that the next line of code is the creation of the mesh. You can see that I can keep scrolling into, and then you can see that now I'm actually going to be doing the for loop 1, 2, 3, 4. Can you see how this happens? 6, 7, however many times, right? And then the program finished, the function finished, and we're back to the line of code that executed the function. And then I can step into again, and it will move on to the next line of code. All right? So this is a very, very useful thing so that you can keep track exactly of what is being calling whatever. And sometimes you pick up that the for loop is not working because the value is not, or whatever it is, etc., etc. Another thing that is very useful about this is that because the program is paused, you basically have a way, it's like a snapshot. So you have a way to look into the current value of the things that are happening in your program. So for example, if I were to hover over remeshed, you can see that I get this tooltip that tells me that the remesh is now an object of the type G3 dmesh3. And if I were to expand this, you can see that I can now scroll and take a look at the value of all the properties inside. So for example, compact metric is a none, has triangle groups is true. Then for example, triangle count is 0. Okay, that is strange. And for example, vertex count, let's go to vertex count. Vertex count is 726. All right. So this gives me a way to inspect the current value of things. So for example, right now this is going to be executed. You can see the vertex count is this much, triangle count is 0. So I'm going to keep going, and then you're going to see that remesh, vertex count, triangle count. You see? So for example, I have detected that something is strange here. And I have detected that triangle count is 0 and that something is not going to work well. So if I were to now say, you know what, I'm done inspecting, can you please continue executing the program normally? I'm going to press continue, and then I can go back to Rhino, and you can see that now I can move things again, etc., etc. And you can see that something went wrong here. You see, I get an invalid mesh. So this would be a good way now of figuring out, well, I may need to change the method. I may need to take a closer look at what's happening right now. Or for example, you know what? Let's try to do that again. So I'm going to clear the values. I'm going to set one mesh again, and I'm going to start. I'm going to go in, all right? And then you can see before I do any remeshing, the dmesh has a triangle count 0 and vertex count 0. So for example, because I inspected this before we went into any of the remeshing, what I can see is that the problem is not the remeshing. The problem is, for some reason, is the conversion from a Grasshopper mesh, right? Or the conversion from this mesh, the one that is coming in. You see, where is the mesh that is coming in? Yes, the mesh that is coming in that has already, when it came in, it already had 0 triangles. So what we can see is that we have been able to analyze that the problem is not this component. The problem is probably the component before. So let me continue this. Probably the problem is the component before this one, when it's converted from mesh to dmesh, which is not giving me, for some reason, the triangle count. And actually, I do know why this is happening. It's happening because Rhino is using a quad faces, right? And I don't think the dmesh3, I don't think the G3 library accepts quad faces as faces of a mesh. They all have to be triangular faces. So if I were to triangulate mesh, for example, and then I'm going to continue this, you know, this got triangulated, and then I don't know what happened here. Yes, and I think, you see, and now things worked out because the original mesh is made out of triangles, because the original mesh is made out of triangles, right? So now everything works, and this gives me a valid mesh. Okay, so here you go. That was a way of testing things and debugging, right? What's a little annoying about this is that, I don't know, let's say I am on a breakpoint, and let's say, for example, you know what, I'm not very happy with this. Can I actually change this before for the next execution? So remeshed, demesh to, for example, blah, blah, blah. And I'm going to continue. And actually this change actually went through, which is kind of nice because it was a simple string manipulation. But sometimes, for example, if I were to say, I don't know, let's reload again, okay? So for example, if I were to add here int I equals b, I don't know, 10 plus 200 or something, right? Well, I guess that also works. Give me a second. Yes. So for example, let's say that you want to make some changes in the code. Sometimes if the change is minor, the Visual Studio can do things such as just update the code on the fly. So for example, if I can say now message, can I just add to message like something like good luck with it or something like that? This will be accepted. So if I keep going, you can see that now I updated this and it's working fine. But if I try to reload again and I say, well, you know what? I actually kind of want a change that is a bit more significant, a change that is basically rechanging or reshaping the structure of the code that I'm writing. So for example, an example of such change could be changing the signature of a function. So let's say I want to have this function be able to now accept, for example, prevent normal flips as an option. And then I want to use that here because I want to be able to customize that. You can see that my code is complaining here. We're not seeing the highlight, but basically what it's saying here is that it cannot keep going with this code. So for example, this would be true. it cannot keep going with this code unless it recompiles again. So if I try to go and continue, it says some edits were made which cannot be compiled, so execution cannot continue, etc., etc. So just either stop debugging and then start over again, right? And then everything goes well, start over again, or don't do those changes, right? So when you want to make those more significant changes, basically, Visual Studio Code cannot allow, Visual Studio doesn't allow you to do that because it needs to recompile things, okay? So, well, that is kind of a limitation, depending on how you see it, but there is another technique that we can use to work around that. And that is that instead of using breakpoints, what we can do is we can use this thing called hot reloading, all right? Let me show you what that looks like. For these videos and for this series, I've been mostly using Visual Studio version 2019, the Community Edition. But actually, if you download the latest version as of the recording of this video, which is 2022, then you will find that this version actually has this new feature called hot reload, and that is actually quite cool. So if I open now the project with version 2022, and then we go back to the remesh file that we were working on, you will see that there's something that I can do here now, which is I'm going to run the project under Visual Studio. So I'm going to open Rhino, I'm going to load this mesh, etc., right? And then, and then I'm going to open, oh, hey, what happened here? Let me take a look at what's going on here. Yeah, sorry for that. So I loaded the plugin, I opened the components, and then I have my Grasshopper script, it's working, and everything is going great, right? So one thing that's interesting about Visual Studio 2022 is that it's had this feature here called hot reload. What that means is that I can do also small changes to the code, which then I can push directly and have updated in whichever instance of the software that is managed by Visual Studio is running. So for example, let's say that I want to say message, I want to include, for example, I want to add like, for example, another message saying, this was great, right? And I want to push that. So what I can do is I can click here on hot reload, and what that will do is that it will automatically update the code that is already running, so I don't have to open and close Rhino again. And you can see that if I make, for example, any changes, so for example, clear the values and then let me load the mesh again, right? So you can see that now the update is giving me the correct changes that I've made here in the component, right? Which is great. So as for the issue that I was discussing before, so remember how we made changes here that were structural? So what I can do is I can now change this and revert it back to not having that signature change. But as I was recording this video, for some reason, I thought this was a possibility. I swear I remember making deep changes in the code and being able to hot reload them, but I'm finding that I can't do this for this reason, for some reason. So if you're watching this video and you know why this is happening, because I swear I remember doing this, maybe I'm wrong, but if you're watching this video and you know why this is happening, please leave us a comment in this video. And if I have remembered why or how to do this, and if I have remembered in the future after I record this video, there will be a link popping out in a card here on the top left corner or in the description, linking to a video where I explain what the issue was and how to fix it, okay? So yeah, so for now, I think deeper, more meaningful changes need to go through the process of recompilation and restarting right now, okay? Sorry about that. Beautiful. So we've seen breakpoints, we've seen hot reload. What else could we use as a way to figure it out and debugging and improving our code? One thing that we can take a look at is how to measure performance in our code. Let's take a look at what that looks like. A really nice trick that I like using in C# is called the stopwatch class. It is basically this very simple utilitarian class that is very helpful to measure the time certain code takes to execute. So there's actually a documentation that you can check. It's very simple. You can basically instantiate a new object from the type stopwatch, and then you can wrap whichever code you think it's heavy duty. You can wrap it between a start and a stop call to that timer. And then once you do that, then you can read how much time has elapsed from that object and print it to the console, use it somewhere else. So for example, right now I have Rhino and Grasshopper open. There's nothing going on here, and I have my code in running mode. All right. So what I'm going to do is I'm going to say, well, I think this remeshed operation, this function is probably heavy duty. It probably takes like quite a few cycles because it's a very expensive operation. So what I'm going to do is I'm going to define here a variable of the time stopwatch. All right. Then I'm going to call timer, and it's going to be a new instance of stopwatch. I don't know if you notice, but Visual Studio on my behalf already added here a link to the namespace system.diagnostics, which is where the stopwatch class lives. If your Visual Studio didn't do that for you, you may have to manually type here using system.diagnostics. And then what I'm going to do is I'm just going to say here, can you start? I'm going to start right before the heavy function, and I'm going to stop right after the heavy function, which is the one that I wanted to measure. And then I would like, in this message, I would like to also add like a little bit of like how long it took to compute. So I'm going to say computed in, and then I'm going to go to the timer, and there's a bunch of things. So I can use elapsed, which is the time in seconds, I believe. Forget about that. Or the time in milliseconds, which is usually a bit more useful. So I'm going to print time elapsed milliseconds and then ms. All right. And then I'm going to hot reload. Then that saves me from having to open and close Rhino again, etc., etc. And because it's a minor operation, what I'm going to do now is I'm just going to go ahead here and load the components, show, and then I'm going to load this mesh, and you can see that the operation was computed in 26 milliseconds. So this is actually quite helpful because if we're working, so I have in Grasshopper, I have turned on the profiler option, which gives every component this pop-up with a measure of the time it takes to execute, which happens to be almost identical to the time it took to compute. It's just 1 extra millisecond, which is probably like running the component, like passing in the inputs and outputs, etc., right? But you see that it's actually very, very close, right? Which is a good indication that this is working well, okay? And this is actually quite useful because if you are working in an environment that you don't have this kind of tooltip, like a console application, like Unity, whatever, then taking a look at this is actually quite helpful to understand which parts of your code are heavier and which ones are not. Okay, so use a stopwatch a lot to measure the performance of your code. And the last thing that I wanted to explain was, if you have noticed when I'm loading, when I start a project from my plugin, what I have configured Visual Studio to do is to open Rhino automatically, but also to open Grasshopper and to open it with this particular file that I have on my desktop and that I keep using over and over for debugging. It's basically a file that has all the components. It has one instance of all the components that I am developing, right? So this helps me do this very fast because otherwise every time I would click execute, I would have to open Rhino manually, I would have to open Grasshopper manually, I would have to find the file, etc., etc. So it turns out that the way to do that is by going to the CS project file and then making sure that you add here in the start arguments, when you open Rhino, start a script that opens Grasshopper and that opens a particular file that is living on your desktop or whichever. I was going to explain this, but I just realized that I have forgotten that I had explained this in a previous video when I was explaining how to streamline Grasshopper development. So I'm not going to go over again. There's going to be a link popping up on a card here in the corner to this video if you want to learn more about how to streamline and how to connect the dots and open up your Grasshopper definition automatically. Okay, beautiful. Well, with that, I think these are the few tips that I wanted to give you for development, debugging, and testing your code when you're developing Grasshopper components. I hope that is useful. And then I think at this point, you have most of the basics covered. We know how to write code, how to develop it, how to debug it. I think what I would like to do next in my next video is probably give you some pointers about once you have your fantastic Grasshopper plugin developed, how to actually just push it out the door, how to make it available for people out there in the wild. Okay, so let's take a look at that in the next video. And in the meantime, if you found this useful, maybe like it, subtract it, pushy, all those buttons, or just say hi in the comments. That was also pretty good. Thank you very much, and see you on the next video. Bye bye.